Good afternoon, everyone. Welcome to the Annual Climate Statement 2021 webinar. For those joining us for the first time, welcome. And for anyone who's joined us for our webinars before, welcome back. Before we begin proceedings, I'd like to acknowledge and pay respects to the Kulin Nations, who are the traditional custodians of the land on which we meet. I would also like to acknowledge and pay my respect to the traditional custodians of the land that we all gather on in all states and territories, and pay respects to their elders past and present and emerging. We acknowledge and respect their continuing culture and contribution they make to Australia. So today you'll get an in-depth look back at the climate of 2021, including the official summary and contextual information on temperatures, rainfall, and significant weather events for the year. My name is Jordan, I'll be your moderator today, and I'm joined by Tegan, who will be producing today's webinar. Together, we will help make the webinar as interactive as possible. But before we start, may I ask for your attention as we cover off some housekeeping items. With the situation as it is in Australia, this webinar will be conducted from our respective homes and office spaces across the country. Please bear this in mind as we may encounter some technical issues during the broadcast. Our broadcast today will go for 60 minutes with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen now. Most importantly, please note the chat box where you can send through any questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session, and we will answer as many as possible during the allocated breaks. It is the speech bubble button on the right of your screen. You'll find it next to the participants button in case you're looking for it, and the icon will change color when it's on. And lastly, please send your questions to everyone in the options so we can all see them. If you want to test out the chat box now, feel free to tell us your name and where you're dialing in from. We want to extend a huge thank you to everyone who has sent in questions during the registration process. We've used them to help shape the content you'll see today, and we'll get through as many as we can. Finally, I'm delighted to introduce you to our presenters. From the Bureau of Meteorology, we have Senior Climatologist Lynette Bedio and Senior Urban Hydrologist Andrew Terracini. Lynette is a Senior Climatologist in the Climate Services at the Bureau of Meteorology and has a PhD in Climate Science. The Climate Services section is responsible for the preparation and analysis of Australia's climate record and provides capability for outlooks, predictions, and projections. Andrew Terracini is a Senior Hydrology Specialist in the Climate Environmental Prediction Services. He joined the Bureau in 2019 and played an important role in the stakeholder consultation and development of the Australian Water Accounting Standards at the Bureau's National Water Account. We also have Janice, Rob, and Andrew, who will be answering questions in the background. These are the best of the Bureau looking after today's webinar. So we have a packed hour for you today, including a 2021 wrap-up and an insight on the significant weather events of 2021. So let's not keep you waiting any longer and get straight to Lynette. She'll start us off with a look back at what happened in 2021. Don't forget, you can get your questions answered today, so send them in as soon as you think of them. All yours, Lynette.
Thanks, Jordan, and thanks everyone for joining us today. Really happy to talk to you about what we saw in 2021. So I'll be giving a bit of an overview of 2021. I'll be talking about largely the rainfall that we saw and the temperature that we saw. And then Andrew will be talking about the impacts that this had on our water situation, on water storages, water in the landscape. And then we'll have a little bit of a quick look at some of the events of 2021. And I do encourage you, as we'll go through, you'll see the links, but to read the annual climate statement for more detail. So this is really just a taste of what we've got in the statement. So rainfall in 2021 was 9% above the 61 to 90 average. So we use that averaging period just to get it's a nice a 30-year period. So it includes some of those drivers that are cycles of drivers that affect our climate in Australia, such as El Nino, La Nina, as we've got currently, and the Indian Ocean, dipole Indian Ocean as well. So really gets a good basis for comparison. So we can see in comparison to that period and in comparison to other years, looking at that larger picture there, the rainfall over the whole year, we've got a little blue little blue column. So on the right hand side there. So it was a little bit a little bit wetter than the average, but and also looking towards recent years, you can see that really big red column going down. So 2019 was Australia's driest year on record. So we know from 2017 to 19, we had that really severe drought period. Really, we saw those very dry conditions over Australia. So really starting the recovery from that severe drought, continuing that recovery in 2021. So we also had some standout months. So November was the wettest on record for Australia, and we'll talk a little bit more about that later. And we also saw the second wettest March on record for New South Wales. So breaking that down, we know that we get rainfall at different times of the year across Australia. So looking at that cool season, that April to October rainfall anomaly for southern Australia. So really it's an important agricultural time of year for that part of the country, and also important time for filling up those water storages. So it's actually for that April to October period, averaged over all of southern Australia. We can actually see the trend there that we've seen in recent years towards drier than average, tending towards drier than average conditions over that April to October period, with only a few of those real recovery years across that. But that doesn't quite tell the whole story, and we'll go into it a little bit in a little bit more detail, where we actually saw parts of southwest Western Australia saw their wettest April to October period in over 20 years. So really, really going against that long-term trend. What I also, and so sorry, looking at the northern wet season there, the rainfall anomaly, so that bottom graph on the right there. And so what we have seen this past 2020 to 2021, so the wet season that finished up in 2021, and you could see we had those wetter than average conditions across the north there for that northern wet season, and that followed 2 years of below average wet seasons. And Andrew will go into a little bit more detail about the impact that has had on water storages in northern Australia. And what I was going to say was that you will notice that a lot of these graphs tend to there's a lot of blue and there's a lot of red, so they're going up and down. So every year we have that variability. So we have variability due largely to some of those drivers that affect the Australian climate, such as El Nino Southern Oscillation, or ENSO, and the Indian Ocean as well. But as I said, with that cool season, April to October rainfall anomaly on the top right-hand side there are some trends in that some parts of the country, for rainfall, but especially with temperature, but for rainfall, there is a tendency tending towards drier than average April to Octobers across southern Australia. So what does that look like when we look at it on a map? And this is what we call a decile map. So if you took all those years that we saw on the previous graph and stacked them from the driest to the wettest, and then you took the bottom 10% and the top 10%, that's what you're looking at here for every grid point in Australia. So not averaged across Australia, but for every little grid point, we stack up all the years from 1900 to 2021, and we see what was the 10% of the wettest years and the 10% of the driest years. So with that 10% being in blue there, shade darker than the lightest blue, very much above average rainfall. And you could see it in 2021, it was a real story of that very much above average rainfall across large parts of the New South Wales, large parts of the Murray-Darling Basin going into eastern Victoria and southern Queensland there. Also some parts of northern Australia and or, as I said, in Western and parts of southwestern Western Australia. So just in comparison to 2020, when we were coming out of that drought, that dry period, we saw some recovery with the La Nina in 2020, but really continuing that recovery, especially in the east in 2021. Large parts of Australia were close to average, and we did see some parts of Western Victoria into southeast and South Australia there below average rainfall for the season. So going on to temperature, and as I said with rainfall, there's large variability in the temperatures that we see. So I wanted to show you this graph. This is in the statement, and so you can go and have a look at it. So temperature overall was 0.5 to 6 degrees above average. So the 19th warmest year on record and the coolest year since 2012, also 2012 coming out of a La Nina event. And what we can see here, so we do see that variability in the signal, but there is a tendency towards more recent years being warmer than average, so warmer years in more recent years. So with El Nino tending to promote warmer conditions and La Nina tending to promote cooler conditions. So we can actually see by looking at this graph that it was actually the warmest La Nina year that we've had in this record. So really, really that strong, there's that trend with climate change, but variability is still going to happen on top of that. We're still going to get cooler years, we're still going to get warmer years if all the ducks line up, but there is that underlying trend there. And again, what does that look like when we're looking at a map of Australia? So again, we stack all those years up from 1910 to 2021, and we look at every grid point, and we look at the top 10%, and we can see that parts of northern Australia there were in the very much above average, or the warmest 10% on record. And we can also see parts of large parts of the country above average. So above average to very much above average, or in that top 30%. We did see some cooler areas with all that rain that we saw in New South Wales. We saw below average temperatures there. And I should say mean temperature, it's just the average of the daytime and nighttime temperatures. So looking at both of those together. So not just, those hot days, not just or the nights, but looking at those together affecting our climate. I just wanted to pull out there. So it was the 4th warmest winter on record. So looking at just a similar map for just winter, and we can see large areas of that top 10% across the country. So very much above average over large areas of the country for winter. So sea surface temperatures, we're also seeing these underlying trends in the sea surface temperatures around Australia. So, looking at the 0.52 degrees Celsius above average and the 6th warmest year on record. So again, year-to-year variability, but a strong trend there towards warmer than average temperatures, and large parts of the ocean surrounding Australia very much above average temperatures, or that top 10%. So I'll pass over to my colleague Andrew now, who will talk about the year in water, or how the climate impacted on the water situation. Thanks, Andrew.
Yes, thanks, Lynn. Hi, everybody. Yeah, I will provide a brief overview of the impacts of the storage and the landscape for 2021. I'll start with soil moisture, and I'll go through stream flow storages and the groundwater effects. So starting with soil moisture, what you'll see, the map here is very similar to the rainfall slide, which I've also showed on the left-hand side of this slide. The map is in deciles. And you can see that soil moisture has improved significantly across Australia in 2021. And this was mainly due to the rainfall patterns that we received at the end of the year, mainly during November and December months. As illustrated on the slide, the eastern and northern Australian experienced above and above average soil moisture. But if you can see consistent though with the rainfall decile map that Lynn had discussed, East and South Australia, and over in central Western Australia and Western Victoria, they experienced below average soil moisture. And this is due to those dry conditions. There are still areas of Australia that also did experience actually below to very much below average soil moisture. They can be seen in Western Tasmania. You can see how dry that was, just very average there. And then Western Victoria and the areas bordering in East and South Australia. Southwest Western Australia also had very much below average soil moisture. We go to the next slide, please. The stream flow conditions though reflect the above average rainfall and also the soil moisture. In northeastern and southeastern New South Wales, which received very much above rainfall and experienced very much above average soil moisture, saw many rivers observe their highest on record flows. And they're being illustrated there with those very dark blue dots, with some areas experiencing their worst floods in more than 30 years. South Australia was an exception. You see down there the colours red. South Australia was an exception, but not a surprise due to the rainfall patterns and soil moisture profile. They observed below average stream flow. Go to the next slide, please. Here's a breakdown of 3 months that actually had very high stream flow. So if we can see during March 2021, due to a blocking high pressure system in the Tasman Sea and a low pressure system off northwest Australia, most central catchments in New South Wales and some adjacent parts of southeast Queensland and eastern Victoria experienced flooding, with the Camden, Haven and Manning rivers and the Hawkesbury Nepean catchment in Sydney experiencing its most significant flooding for more than 30 years. Then later in the year, heavy rainfall in November resulted in widespread flooding events again on the eastern parts of Australia. The most significant flooding was in the rivers of the Murray-Darling Basin, particularly in the Lachlan River. Flooding continued into early December when major floods were observed in McIntyre Weir, Barwon, in the Namoi, Lachlan, and Hunter, to name a few. Can we have the next slide, please? There was improved rainflow with the improved rainfall and stream flow conditions. We saw an improvement in the amount of water stored in a lot of our major storages. That related, we had 52.2% at the beginning of the year. At the end of 2021, that had risen to an average of 21.5%. In the urban centres, the storages that supply Canberra, Sydney and Hobart all maintained the full storage volumes that they had achieved during the 2020 year, with Canberra ending at still 100%, Sydney had 95%, and we had Hobart at 98% full. Next slide, please, for the Murray-Darling Basin. In the Murray-Darling Basin, the major water storages recovered significantly in 2021, increasing to 90.7%. This was compared to 57% in 2020. During the year, some of the storages spilled or were operated to prevent spilling. On the top right, we can see the Northern Basin, and you can see how much that has really recovered. The storages started actually at a very low 24.9% and finished the year with storages at 96.5%. This was the highest levels since May 2012. It was the widespread rainfall events in March that started this recovery. Storages rising from 27.9 to 47.1 in the month of March. There was also another large rainfall event in November which saw storages starting to spill. The Southern Basin on the bottom right started the year at 64.5 and also had an increase to finish at 89.4. We go to the next slide, please. Down in Menindee Lakes, the above average stream flow and flooding events in March in the northern Murray-Darling Basin, those waters actually started to flow down and actually reach the Menindee Lakes during April, with the storage volumes recovering from 13.5 to 30% by late May. Menindee Lakes was at 57.7% before peaking at 114% of capacity in October. This was the highest levels since 2012. At the end of the storage volume, at the end of the year, the storage volume had reduced to 93.5%. This was mainly due to releases being made to accommodate waters from upstream from other flooding events during November and December. Slide 7, please, for Queensland. There's a different story up at Wivenhoe, the largest storage in southeast Queensland. They started the year at 39% and finished the year less than 50%. This is mainly due to the observed rainfall occurring in the neighbouring areas, which missed most of the catchment for Wivenhoe. In central Queensland, storage had some increases in the Bundaberg system, which includes the Fred Hay, increased to 51.7 compared to 40.6 in 2020. Fairburn storage also had an increase from 27.8 from a very low 7.2%, I'm sorry. Another water storage is over in the Argyle, which is the next slide, please. Up in the Northern Territory, Lake Argyle, which is the largest water supply dam in Australia, saw some recovery during 2021, but it failed to spill for the fourth consecutive year, only reaching a maximum of 82.4% in March. We go to the next slide, please. Over to groundwater. High rainfall and flooding in some areas started to restore groundwater levels that were low due to reduced or no recharge and increased pumping associated with the prolonged drought conditions from 2017 to 2020. Regionally, groundwater levels were average to above average up in the northeast Queensland and the top end of Northern Territory due to the high rainfall events from the La Nina and a good wet season in early 2021. Over in the northern Murray-Darling Basin in southeast Queensland, saw some recovery of groundwater levels due to increased recharge and reduced pumping associated with the heavy rainfall and the flooding in March, and again back to those flooding events in November. In contrast, many bores in the western and south Murray-Darling Basin remain very low and require follow-up rain to return to groundwater levels pre-drought conditions. In addition, below average rainfall during 2021 in the Victoria, South Australia border regions has further affected groundwater levels in this area. Over in Western Australia, groundwater levels in the Nungarra Mound near Perth generally remained low, but started to show signs of recovery due to the average to above average rainfall in 2021. Prior to this, the Perth region experienced 2 consecutive years of low winter rainfall, resulting in low groundwater recharge and low groundwater levels. This is all from me on the effects of the climate on our water stores and our landscape. I will now pass back over to Jordan.
Thank you so much, team, for starting us off today. Before we find out a little bit more about what drove the climate this year, let's get to some of your questions. Now, remember, hit the little speech button on the right of your taskbar and start sending them in. And make sure you're sending them to everyone as well, so we can all receive them. And you can see that we've got our full full team on deck to answer your questions. So jumping straight into it, we have one from Marty, who's said, "What are the projected impacts from this year on next bushfire season?" I know this is always a really important topic for a lot of people around Australia. Lynette, I think you'd be the best person to ask about this.
Yeah, so thanks. That's a really good question, and really important in that the coming bushfire season actually depends on what the conditions are going to be, but also those conditions that we've had, as you just said. So at the moment, we're helping the bushfire agencies around Australia with climate information to prepare the Australian bushfire outlook for autumn, and that will be coming out in the last Thursday of the month. So keep an eye out for that. I will say though, I will touch on in what we've seen so far in southwest WA. So I did speak about that rainfall that we had, which was a blessing for many agricultural producers in the areas, but that also created a lot of vegetation growth in the area. So when we did get those warmer temperatures over summer, we did see a lot of drying out of that vegetation and some severe fire weather with that. So really, as you've asked in the question, it is really important to keep track of those conditions that we've seen, and we do work with fire agencies around Australia to keep track of that. And I just will also add in there that we're seeing trends in fire weather conditions across Australia. So I really recommend you go have a look at the State of the Climate report put out by the Bureau and CSIRO if you're interested in some of those long-term trends. Thanks.
Excellent. Great answer there, and fantastic questions. Please keep them coming in. Daniel has asked, is it too early to predict whether we will have a La Nina or El Nino or neither next summer?
Yeah, again, really great question. We've got some really, some people obviously that have been following along and are really interested, like we are, in the climate. Well, at the moment, so we're currently still in a La Nina, and the way the La Nina cycles, I'll talk about it a little bit more, is that we do usually see, it usually starts up in winter, spring, and El Nino as well, I should say, and then carries on usually to the autumn following. So we're seeing that that cycle taking place at the moment, where the models around the world that we survey to get the best guidance on what La Nina and El Nino is doing are predicting that the current event that we're in will decay around mid-autumn. So we're just looking ahead. There's no indications from those models at the moment that any El Nino or La Nina event is starting up. That is something that we do closely monitor, of course, because of the impact on Australia. And every fortnight we do put out a climate driver update. I'm just looking at the clock right now. It should be out in about an hour and a half, so Tuesday fortnight. So keep an eye out for that if you're interested, and you can sign up to get these information on when they do get put out delivered into your inbox.
Yeah, the link is e.bom.gov.au/subscribe, or you can find a link on our homepage. So e.bom.gov.au/subscribe, and you can subscribe to all kind of products that the Bureau offers there. We've gotten a message through from Peter, who's asking, what is the likelihood of more intense storms around coastal cities?
Again, great question. So we look towards our outlook, our rainfall outlooks, for the best guidance on what we are expecting for parts of Australia. So I might actually pass that question off and say, and perhaps one of my colleagues might type it in the chat for what that is, what's that saying for coastal cities. From memory, parts of Queensland, those Queensland coastal cities and parts of Queensland had increased chances of above average rainfall. And we also have a new product out too. So if you're looking at that extreme rainfall, we have a product out there looking at that chances either of extreme wet or extreme dry conditions. So yeah, I'm sure one of my colleagues will post a link to that in the chat, and that's something to keep an eye out for.
Great, thank you.
Sorry, I'll just add in there, we use dynamic models because it actually integrates all the drivers, all the impacts of those drivers on Australia. So you're not just looking at what are the average conditions during a La Nina event, but it all takes into what's happening all around Australia as well.
Okay. Also, we've gotten a question from Greg. I think this is a good one for you to answer, Andrew. What effect has increasing temperature had on groundwater levels over time?
Sorry about that. I was trying to get my mute off. Yes. Well, sorry, can you repeat the question? So that was groundwater levels, the weather.
Yeah. What has the effect of increasing temperature had on groundwater levels? And that is from Greg.
Well, I'm an expert in a lot of waterology, but we may have actually one of our people put something in the chat there. But groundwater levels in Perth have actually been low for a very long time, and the decrease in rain has contributed to that. But also we can say over there in groundwater levels, say in the Perth region itself, they actually use an integrated water system. So what happens there is they also create their desal plant and pump water into their groundwater system as part of their urban supply system.
Okay, great. Thank you for that answer, Andrew. And lastly, before we move on, I've got a question from Gavin, and I believe it was answered in the chat, but I do think it's an interesting point to bring up here so everyone can hear it. He's asked, when you say 2019 was the driest year on record, does that include 1902?
Yes, it does.
That's stretching back a very, very long time.
Yeah, well, no, it's a really interesting point because 1902 we was the Federation drought, and until we saw 2019, it was one of Australia. My colleague might be able to help me out, but I think it might have been Australia's driest year on record up until we saw in 2019. What we have been seeing across Australia is actually Australia's been getting a little bit wetter, and that might sound counterintuitive, but what we've actually been, because we think, oh, it's been getting drier, but what we've actually been seeing is increased rainfall in the north in the monsoon season, which brings a lot of rainfall onto Australia. So so we actually, if you take, which is why I don't really like to look at Australia as a whole sometimes, because it actually hides a lot of the stories that are going on. So yeah, so if you do, and what we saw in 2019 is we saw that lack of monsoonal rainfall. So it was very dry, and we did have those drying trends that we've seen across Australia, but also on top of that, some of those climate drivers which swing the needle towards dry conditions. So really reinforcing some of those trends that we've seen without that lack of increased monsoonal rainfall.
Okay, well, we do have to move on now, but there will be another big Q&A session coming up later. So you've got from now until the end of the presentation, or about 10 minutes away from the end, where we will get straight into as many questions as possible. So we want to hear from you. Get into the chat, start sending them through as soon as you think of them. This will be your last opportunity to ask all of our panelists. I'm going to hand it back over to our presenters now to take us through the next section.
Oh, that's me. Just trying to
All good. I believe you're going to
So
talk
let's move on.
about the climate drivers we experienced in 2021.
Yeah, thanks, John. So as we've discussed, one of the big climate drivers really bookending 2001 was the La Nina event. So the wetter side for Australia of the El Nino Southern Oscillation. So the El Nino Southern Oscillation, it's really looking at sea surface temperatures in the tropical Pacific. And I like to say, so our threshold for those sea surface temperatures is only 0.8 degrees Celsius. So it's one of those little numbers that doesn't sound like much, but can have a big impact. So what we see is really an enhancement of the typical situation. So we have stronger trade winds in the Eastern Pacific and warmer, driving those warmer than normal sea surface temperatures closer to Australia. So cooler than normal sea surface temperatures in the Eastern Pacific and warmer than normal sea surface temperatures in Australia. And that really increases convection in our region and increases that moisture. That warm air can hold more moisture, that convection, so it really increases the chance of rain in Australia. So as I said, the start of 2021, we were finishing off a La Nina event, the 20 to 21 La Nina, and then we're actually then that died away. We actually saw some other drivers in the year throughout the year, which I'll discuss in the next slide, and then we saw the La Nina start up again in late spring. So really impacting on our climate and really that continued recovery from those really dry conditions in 2017 and 2009 to that 2017 to 2019 drought. La Nina, some of the typical impacts there really typically increases rainfall across large parts of Australia, especially in the north and east, but bit more of a signal into central Australia than what we see during the El Nino side, but also increased chance of widespread flooding and interestingly longer duration heat waves in the southeast, but less intense. So we don't really get those really, really hot days, but we get more of those really warm days, those heat wave conditions. And I just will add into really with that bookending of the La Nina. So what we do see is when you start to wet up the landscape, when you start to fill up that soil moisture profile, fill up those storages, so rainfall, it doesn't have to be above average, doesn't have to be really intense to increase your chance of getting floods. So what we saw going into the La Nina event that we've just had, we weren't looking at a La Nina like the very strong ones that we saw in 2010 to 2012 with those huge floods across Australia, but we were starting to see that we had seen some rainfall with the 2021 La Nina, which again was weaker, and we were forecasting a weak to moderate La Nina event, but we had seen with that March rainfall, we had seen those water storages, that water situation starting to increase. So certainly we're looking at the impacts of the La Nina event, being higher than perhaps what the actual strength of the event might have indicated. What we also saw during winter and spring was a developing, and then we went into a negative Indian Ocean dipole event. So negative Indian Ocean dipole, very similar to what we see with El Nino and La Nina in the tropical Pacific, where we have those cooler than normal waters this time in the west of the Indian Ocean and warmer than normal sea surface temperatures near us in Australia, again increasing convection in the region and really increasing that tropical moisture coming down. So you might have noticed some of those really muggy days, or those down in the southeast. That's where I am at the moment. But so we saw some of those that rainfall. We saw those floods recently in South Australia, not in 2021, but just really increasing that tropical moisture and those tropical conditions coming down. So again, cooler days in the south with that increased rainfall, but warmer nights in the north and increased chance of flooding. So we're starting to load the dice, or load the odds here. We've got two wet drivers impacting on Australia. And what else did we see impacting on Australia? We saw the southern annular mode, and typical impacts in a positive phase of the southern annular mode. You can see on the right hand side there. So southern annular mode, changing where that sort of belt of westerlies come through. So really increasing that chance of increasing that onshore flow into New South Wales there and southern Queensland, but perhaps drier than average conditions forecast for Western Tasmania. And so southern annular mode is usually quite variable, but we did see a real sustained phase of the southern annular mode, really sustained positive phase. So again, really increasing those chances of wetter than average conditions. And when we saw all those line up, we saw November, we saw Australia's wettest November on record. You know, we had the developing La Nina, we had the negative Indian Ocean dipole, and we had the positive phase of the southern annular mode. So really, these drivers can really impact Australia, but we don't look in at any one driver in isolation, because it's never any one driver that's impacting on Australia. So we can see that all of these factors go to combine. So even, you know, though it's sort of green there, you might not be able to see, but that factor, that the positive phase of the southern annular mode, Western Tasmania there, tends to keep drier those more west-facing areas. So, you know, what we saw in Western Victoria, for instance, and southeast South Australia may have impacted on that more typical La Nina wetter signal. So really all of these drivers acting together. And I will say again, to get the outlook, rainfall outlook for all of these combined, we're looking at our outlooks, which use a dynamical model, much like a weather forecast model, that can combine all of these and look at the odds of receiving wetter than average conditions or drier than average conditions. But of course, knowing, you know, if we're in an El Nino event or La Nina and it's likely to last, gives you more confidence perhaps in that outlook, or more understanding. So just talking about some of the events that we saw now. So these aren't, of course, and I do encourage you to go to the annual statement, and we actually have separate statements, annual statements for every state and territory and many capital cities as well. So I do encourage you to go have a look at our website, and the links will be there after the event, because to find out more information. I've just selected these as a bit of maybe a few standouts and a little bit of a range of what we saw during the year, but it's by no means exhaustive. So Andrew talked about that March extreme rainfall and flooding in eastern and central Australia, and for me this is probably I saw someone's question pop up in the chat. What were some of my highlights? I think that first dot point, the second dot point is one of my highlights. During the 2017-2019 drought, when we saw those storages in the northern Murray-Darling Basin go to below 10%, at their lowest point, and then in 2020, we had that La Nina. We were hoping for more of a recovery, and then we saw up to 20-something%, but so it wasn't that really strong recovery that we were hoping for from the La Nina event. And then we saw in the northern Murray-Darling Basin, which can get can experience some of these large increases, whereas the southern Australia tends to be more steady. But we had northern Murray-Darling Basin catchments had 2 of their 3 largest one-day increases in water storage levels since comparable records began in 1993. So with drought being a strong interest of mine, and just watching some of that recovery over the year has just been something that I've just been really really thankful for, but really interested in as well. So also really interesting was someone asked about the conditions leading into the fire season. We're also in climate, we're also we're looking ahead, but we're also looking backwards as to what is the current situation, that how may that impact that forecast. And so with that 2021 La Nina, we saw that increase, as I said, in that soil moisture and runoff. So in March, we actually saw a very similar situation to what we saw in February 2020, but coming off a drought, we did not see nearly the amount of flooding and severity of flooding with that event. But in 2021, where we had those wetter soils, where we were able to start filling up those storages, but also large extreme flooding. So really, really talks to the importance of those antecedent conditions. Another one that I've got here is severe tropical cyclone Seroja across the coast of Western Australia. Now, by no means the most intense tropical cyclone to ever cross the coast of Australia, but really, really unusual in that it was very, very far south where it crossed the coast, and it was able to maintain its intensity going very, very far south. So impacts at Kalbarri and the nearby town of Northampton were very severe. So those buildings weren't built to, or perhaps they weren't as built to handle a tropical cyclone as what some buildings would be further north. So just talking, so that just really something to think about. Those extreme events really also highlights the vulnerability if they're occurring in places that do not have the infrastructure, do not actually have, do not usually see such events. So can really increase the damage. And Australia's wettest November on record, just looking at that map, that decile map that we're familiar with now, and you can see we've got some really dark blues on there. So, and this is without a large amount of rainfall coming from the north as well. It's all across across the central and eastern Australia there. So very much above average across a large area, and also highest on record across a large area as well. We can see in Queensland there, especially, that had been recovering from drought in that coastal area there, and they just had a very wet November. We also can see large parts of New South Wales and South Australia into Western Australia and Northern Territory there really had a really wet month. And I just stacked it up so you don't have to look at the anomalies or comparison with average, just comparison to rest of November's across Australia, and you can see how high it is there. And you can also see in 2019 Australia's driest November on record. So just 2 years later, we go to Australia's wettest November on record. So a real contrast there. And just finishing up the year with heat, a real story of really a number of severe heat events, heat wave conditions, a number of times across, especially that northern Australia there, but then at Christmas Day with that run of heat wave conditions that we saw in Perth. So really, where Perth saw 4 consecutive days with maximum temperatures reaching at least 40 degrees Celsius. So really, really strong heat wave, severe heat wave conditions there. Marble Bar, I don't know if anyone's listening from Marble Bar, but I feel for you. 16 days with maximum temperatures of 45 degrees Celsius or above in December. I think that's too hot by anyone's reckoning. So I'm just going to stop it there. I think that's the end, and I think we've got time for a few questions.
Yeah, we definitely do. This is the last chance you'll have to talk to our panelists, so please send them on through and we will get to as many as we can. There was a lot of information there. All our presenters are back on deck now to answer these questions, so any questions that you have, please send them in now. And we have gotten one from David. He said, I noticed more tornadoes are being reported over the current storm seasons than previous. What do you believe is the cause of this?
That's again a really good question. We do, contrary to what people think, we sometimes think, and myself included, we do get tornadoes in Australia, but you're right, there seem to be a few that were in particular impacting on we saw the results of those tornadoes impacting, and just generally with the increased I suppose energy in the system with the La Nina, that increased moisture, that increased energy we saw can create conditions that are perhaps more conducive or able to be formed. But there were a number of weather conditions that of course led to that. So yeah, no, good question. And I don't have the definitive answer for you, sorry, but one of my colleagues might be able to make it a bit clearer.
Okay, thank you. Stuart has asked, is climate warming affecting the impact of recent La Ninas? The last few for Queensland have only achieved slightly above median rainfall.
Oh, good question.
You
That could be a
know
tricky
you've got
one
you when you go,
a
oh.
tricky one to end out with. Look, there is a lot of work going on the impact of climate change, and certainly we have seen, if you look at the State of the Climate report, those, like I said, for that April to October period, and even for the October to April period, we do see, especially in parts of southern Queensland and southeastern Queensland, tendency towards below drier than average conditions over that 20-year period compared to all other periods on record. So, perhaps the La Nina, it wasn't a very strong one. It was, it was the last two that we've had, were somewhat weak and moderate, whereas, 2010, 2012, where, you had those big pumping La Ninas, no one could escape. But perhaps this La Nina had to work a little bit more uphill if you're sort of working against some of these long-term trends like we see with the temperature. Working against that cooling didn't was working against that long-term warming trend. But this is certainly an active area of research and something that we're very interested in, how climate change does interplay with all these drivers. Great question.
Excellent. Johan has asked a bit of a question about that interplay between ENSO and IOD. He'd like to know, are we seeing any change with the coupling or decoupling of ENSO and IOD due to climate change?
Oh, you're going to get me with all the tricky ones at the end.
They're the best ones. We've got to ask them.
No, and again, a very good question. So you tend to see those La Nina events and IOD events going together. So that's a great question, because you think about it with the La Nina event, those has the warmer waters near Australia, and the negative IOD event has the warmer waters near Australia, and that circulation certainly isn't happening in isolation. So whilst I talked about them separately, you're quite right that they should be talked about together. And whilst I'd have to go back to my books and look at the interplay, there is some research saying that we could get more intense events. But as to the coupling, and then not only the coupling, but then the impact on Australia itself, it's a very very big question. But it's, again, certainly something that we're actively researching, because it's such an important question.
Mm.
I
Jane has
think my
asked.
colleague might be answering as well. So
Great. That's why we have them in the background. And a big thank you
yeah.
to Janice and Andrew, the other Andrew. And we've also got Rob in the background answering questions today. So you might have received a text answer for that. Could you please talk through, this is from Jane, the SAM rainfall effect a little more? I seem to recall that positive SAM had drying influence across Victoria.
Yeah, so it can, Sam's a tricky one, because it changes with, it's not just one dry or wet like El Nino or La Nina. It actually changes with the season as well. So because we're talking about where that belt of westerlies, where that sits, and that belt itself changes with the seasons, it can it can change seasonally, whether it can be wetter or drier than usual. So we've actually got some really great videos on this. So if one of my colleagues will pop in the link to those educational videos, I encourage everyone to go have a look. We've got some great videos on El Nino, El Nino, La Nina, ENSO, on the IOD, on SAM. So go have a look.
I remember learning about what Sam was with a little video about a dog. I don't know if that's the
Oh
same
yeah,
one that you're
no,
talking
please
about.
do. No, and that's a great series as well that was put out by, at the time, Victorian DPI. So if you Google climate dogs or
That's it.
climate dogs Victoria, you might get those ones there. They're great. And we worked on they helped bomb the Bureau. We helped inform the science around those as well. So yeah, great
Excellent.
set of tools.
Yeah, if you wanted a little bit easier, look at the Climate Talks one. I know that one was much easier for me to understand. Jane has, sorry, we had that question from Jane. Sarah would like to know, are the heat waves in December 2021 and Jan 2022 in WA linked to La Nina, and what are the drivers for this extreme heat?
Yeah, really. I keep saying great questions but
They're all
it's
great
true.
questions.
Okay, these are really great questions. What we saw in with a La Nina, usually tend to see the monsoon hit a bit earlier. So, but we didn't see that this year. So usually, once that monsoon's in kicks in, you've got more rainfall, and you don't see those really long lived heat conditions. There was what we would call a tropical cyclone happening in the northern hemisphere that actually, kept some of that circulation further north, and really didn't hit as early as what we would typically see during a La Nina. So we actually, you know, we still, sort of coming out of the dry season for that region, was able to get that big, so that build up of heat, and with some of the weather conditions that we saw, really, yeah, we saw those long-lived intense heat coming through.
Great. Well, that does look like all the time we have for questions today. There was a lot of information in that session to take in. So if you missed the start, Lynette, would you like to summarize what we spoke about today, and more importantly, where people can find more information?
Sure. So 2021, Australia's coolest year since 2012, but it still remained warmer than that average. And we did see slightly above average rainfall during the year, including the wettest November on record. So influenced by the La Nina events in successive summers and a negative IOD, or Indian Ocean dipole, in winter and spring, and also that that's prolonged persistent positive southern annular mode, really that significant flooding that occurred across eastern Australia in March and again in November and December. I think we'll be looking back at 2021 and remembering that flooding, but also that above average rainfall for large parts of the country. So, continuing that recovery that we saw since that 2017-2019 drought. And as Jordan has said, for more information, you can go to the annual climate statement and have a bit more of a look. Individual state and territory statements, our climate outlooks page, our seasonal streamflow forecast page, keep up to date with the climate drivers, and also you can email more questions through and we'll be happy to answer them. Also, I might be jumping on Jordan's toes here, but I'll say keep an eye out for our BOM webinars. Jordan, you might want to give a bit more information around that.
Yeah, bom.gov.au/webinars. We will be doing another one for the next season in a couple of weeks. So really looking forward to hosting this all again and going through everything else. If you've registered today, you'll get an email reminder about it. But that brings us to the end of today's webinar. For questions we didn't get to, weatherquestions@bom.gov.au. A big thank you to Lynette and Andrew for your time in developing the content and sharing your knowledge with us, and to Rob and Andrew and also Janice for answering questions in the background. And to you, thank you for tuning in and joining us today. We hope you enjoyed the session, and we do hope you'll join us again next time. If you'd like to continue the conversation, please use #BOMWebinars in your posts. As mentioned earlier, this session has been recorded, and we will have the video for your on-demand viewing pleasure in the next couple of days, so watch this space. And finally, but most importantly, we want your feedback. It's our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experiences with us. So once we close this webinar, a short survey will pop up on your screen, and we'd be very grateful if you could complete that anonymously for us. We apologize for going a little bit over time, but once again, thank you so much for your time, and we look forward to seeing you again soon. Goodbye.